Good morning, guys. So, ayun, our topic for this week is technically continuation siya for axial deformation or for norm or axial strain axial strain or axial deformation, and technically a combination to summarize this topic. It is combination ng topic natin from first semester, di ba? Kung naalala niyo yung equations of equilibrium and so on. And of course, moment, mga ganon. Tapos lastly, of course, yung pag-solve natin ng stress, di ba? Stress is equals to applied force over area, and pag-solve natin ng strain, which is strain is equals to formula for strain. Strain is equal to stress over modulus of elasticity. 'Di ba? Naalala niyo yun? Or yung technically dito papasok ngayon yung Hooke's law natin. Bukod sa Hooke's law and yung relationship between ng Hooke's law ng deformation, ng strain, ng stress, and then modulus of rigidity, di ba? So ngayon, start tayo dito. Okay? So I hope nakikinig na kayo lahat. So ayan, statically indeterminate members. So sabi dito, when the reactive force or the internal resisting force over a cross section exceed the number of independent equations of equilibrium, the structure is called statically indeterminate. So dagdag natin yung second bullet para mas magets natin. It is the condition where the equations of equilibrium are not sufficient to determine all the reactions on a member. So technically guys, di ba, pag sabi natin equations of equilibrium, ito yung summation of forces natin, di ba? Summation of forces and then summation of moment. So technically, hindi enough yung given data within the problem. So by that premise, ibig sabihin, kailangan pati ng ibang formula to solve it. Okay? So yun yung pino-point out dito. These cases require the use of additional relations that depend on the elastic deformations in the member. So dito lang ipapasok yung axial deformation natin or yung tinatawag natin na elastic deformation. Okay? So technically, axial deformation, elastic deformation is the same. So ito lang sabi ko, marami tayong gagamitin na formula dito. So hindi lang tayo gagamit ng Hooke's law, hindi lang tayo gagamit ng relationship between stress, modulus of rigidity and strain, hindi lang formula for stress, hindi lang 'yon. Sasama na din natin yung mga equations of equilibrium. So para mag-gets niyo yung mga tamang paggamit ng formula, meron tayong procedure ngayon na ginagamit. Okay? So ito siya. Okay. So ayan, procedures for solving statically indeterminate members. So ito yung mga procedures natin. So step 1, step 2, step 3, and step 4. Technically, pwede nyo itong 1, 2, pwede nyo napapagbaliktad yan, pero much better, pinakauna nyo talagang gagawin is mag-draw ng free body diagram. Okay? Technically, yung pinaka-dapat po nang gawin talaga. Okay, draw the required free body diagram and derive the equations of equilibrium. So, ano nga yung mga equations of equilibrium natin? So, nandito naman siya, di ba? Yan. Summation of forces along X or along horizontal. Summation of forces along Y or vertical. And of course, summation of forces moment. So, technically, hindi na natin gagamitin ngayon yung summation of forces. Hindi natin gagamitin yung moment. So, focus na lang tayo. Technically, dito lang tayo magpo-focus eh. Kasi, yun na lang yung nilabas kong mga example problems dito. Okay? So, ayan. Di nyo napaproblemahan yung X and moment. So, next tayo, derive the compatibility equation. So, technically, based dito, parang maghahanap tayo kung ano yung mga equal within our problem. So, mostly, dito guys, sa compatibility equations, ang madalas lumalabas dyan is yung deformation of the two objects. Siyempre, we always can say, or we always assume, na equal yung deformation nila. Hindi pwedeng magkaiba yung deformation nila. Kunwari, patatin sa mga sample problems mamaya kung ano tinutukoy ko. Okay? So, mostly, yung length niya, of course, equal din. And of course, yung deformation, both of them is equal. So, technically, once na equal yung deformation, both side, both material, we can cancel it out na. Di ba? So, next is yung Hooke's law natin. So, yung Hooke's law, naalala nyo, di ba? Yung Hooke's law natin, it starts from here. It starts from stress is directly proportional or equal to modulus of rigidity times strain. Okay? Yan yung original equation natin. And meron tayo, strain is equal to deformation over original length. Diba? Ngayon yung formula na yan, guys. Meron tayong formula for stress na applied force over area. So, i-equate natin yun ngayon. So, magiging P over A is equals to modulus of rigidity multiplied by the deformation over L. Okay? So, syempre, sa Hooke's law, always in deformation. So, paano natin gagawin yun? Paano siya gagawin? So, first, i-transpose muna natin to dito. Magiging PL over A is equals to modulus of rigidity times deformation. And of course, divide both sides ng E. So, deformation is equals to PL over A E. So, ayan. Diyan tayo ngayon mag-iikot ng problem. Okay? Diyan tayo mag-iikot and yung equation of equilibrium natin. So, next, sabi dito, so, last step natin, guys. So, last step, pinakalang natin gagawin is solve the equilibrium and compatibility equations for the unknown forces. Okay? So, once na alam na natin equilibrium natin, alam na natin compatibility equations, we can now solve for the unknown forces. Okay? And of course, huwag nyo kakalimutan to, stress is equals to force over area. So, applied force to over area. Okay? So, ayan. Procedure for solving statically indeterminate members. Okay? So, ayan. Technically, maiksi lang naman yung discussion for this one. Proceed na tayo. Proceed na tayo for sample problems natin. So, we have 4 sample problems here and discuss natin yung lahat properly. Okay. So, first. So, buran na natin yung drawings. So, first, we have here number 1, a steel bar, 50 mm in diameter and 2 meter long is surrounded by a shell of cast iron with a 5 mm tip. Compute the load that will compress the combined bar a total of 0.8 mm in the length of 2 meters. So, for steel, modulus of elasticity is equal to 200 GPa, and for cast iron, modulus of rigidity is equals to 100 gigapascal. Okay? So, yan yung problem natin. Ang hinahanap is yung load na magko-compress. Okay? So, drawing natin siya para magets nyo. Okay? So, yun nga, di ba? Sabi, step 1, draw the required free body diagram. Okay? And of course, derive the equations of equilibrium. So, ngayon, gawin natin siya. Okay? So, gawin tayo ngayon sa whiteboard for number 1. So, ano natin? So, okay. Bale na sa ano na to. Yung PowerPoint, guys, nasa LMS na. So, you can now download it if you want to. Okay? So, yun. So, first, 1. Sabi, draw the free body diagram. So, draw natin. So, sabi, mayroon na tayong steel bar na 50 mm in diameter. So, we can say this is our steel bar. Okay? And then, we have a shell of cast iron with 5 mm thick. So, drawing natin siya technically. Pangit. Teka. Here pa. Alo. Yan. So, let's say, yung blue is the steel bar, and then for red is yung cast iron natin. So, sabi, yung cast iron natin, meron siyang thickness. Ayan. Meron siyang thickness to 5 mm. So, yung 5 mm yan, 5 mm din to, di ba? Okay? So, kung 5 mm both yan, and we have steel bar na merong diameter, ayan, meron siyang diameter na equals to 50 mm. So, we can say that the total diameter, okay, is equal to 60 mm, di ba? 60 mm. Syempre, di ba? 50 plus 5 plus 5, and then of course we have 50 mm. So, para makuha natin ngayon yung mga area, so kung ating area for, so we have diameter for, sabi natin, yung steel is D1, lahat ng unit for steel is naka-subscript for 1, okay? While for the cast iron, ang subscript niya is 2, para di kayo malito. So, D2 we have equals to 60 mm, okay, minus 50 mm pala, technically, dapat ganon. D2 is equals to 50 mm, para makuha natin maayos yung area. Area 2 is equals to pi, big, yan, d squared over 4. So, A2 is equals to, so solve natin para makuha agad natin, guys. 60 squared minus 50 squared, answer divided by 4 pi. So we have area 2 equals to 275 pi mm squared. So kunin mo natin yung mga units bago tayo mag-equation of equilibrium. Okay? So next tayo, dapat hindi ko siya sinulat dito. Sorry. Burahin na natin yung ibang part. Teka lang kulang yung drawing. Shucks. Teka lang, guys. Hindi pa lang natin isulat dyan. Drawing mo natin siya buo. Okay? So of course, syempre yung cast iron natin, nasabi doon. So, kung nabanggit doon na 2 meter long, syempre 2 meter long boat yan. Okay? Hindi pwedeng yung cast iron lang yung 2 meter, hindi pwedeng yung steel bar lang yung 2 meter. So, syempre, let's assume na equal. So, ayan yung cast iron natin. So, meron silang length. Meron silang, ano natin dito? Block na, dahil constant naman. Parehas naman yon. So, meron silang total length of 2 meters. Convert natin to mm for the sake lang. So, 2,000 millimeter. Okay? And, next, ang hinahanap is yung applied load. So, let's say block is yung applied load natin. Okay? So, yan. Find the applied load, di ba? So, syempre, once na sabi din dito, compute the load that will compress the combined bar a total of 0.mm. And sabi dun sa steps natin, guys, hanggat maaari, kung kaya natin i-exaggerate yung deformation, exaggerate natin. So, we can say, sabi natin, na-move siya into this one. Okay? Sabi natin, andyan na yung bagong length niya. Ito na yung bagong length. Okay? This one is yung new length natin. Okay? Yung bagong length, Li. So, we can say that this one and this one to this one is yung deformation natin na 0.mm. Diba? 0.8 mm. And of course, as what I said, may natin ipag-usapan yung deformation. So next, pag-usapan natin, of course, kung meron tayong applied load, guys, hindi pwedeng wala tayong internal resistance. Okay? Hindi pwedeng walang resistance yung steel bar and cast iron natin. So, syempre, We have, kung dito na yung new ano natin, dito na siya. And of course, and yung sa, ayan ito guys, yung P1 natin. So, P1. Okay, P1 siya. And drawing din natin yung sa ano. So, technically guys, yung sa cast iron natin, isa lang yan. Drawing natin properly. Okay. So, ayan. Ayan. So, ito yung P2 naman natin. Isa lang yan as in P2 lang yan. Okay? So, from this, ito na, dito na papasok ngayon equations of equilibrium natin. So, we have here, 3 forces na vertical. So, let's say that, summation of forces along vertical, all upward is positive, equals to 0. So, kung lahat ng upward positive, so we can say P1 plus P2 is equals to, or P1 plus P2 minus P is equals to 0. And we can say that P1 plus P2 is equals to P. Okay? So, ito na yun yung equations of equilibrium natin. So, nagamit natin siya dito based dun sa forces natin. Okay? Yung applied load and then yung internal resistance ng steel bar and cast iron natin. So ngayon, punta tayo ngayon sa mga dimension. Okay? So first, sulat natin yung dimension ng cast iron natin. So katulad ng sabi ko, so yung solve na natin yung A2, di ba? Technically, yun naman yung A2. 275 pi mm squared. Okay? Hindi siya mo ang mm. Ay, nako. Mm squared. Next, meron tayong modulus of rigidity for cast iron na 100 gigapascal. Okay? So, ano pa? Yan lang naman. Kailangan, di ba? So, next, drawing din natin yung sa ano naman? Sa A1. A1 is equals to 50 mm squared over 4 pi. Yun lang naman yun. Di ba? 50 squared over 4 pi. So, we have A1 is equals to 625 pi mm squared and modulus of rigidity na equal to, so E1 200 gigapascal. So, ang gawin natin guys, so technically no need, pakita ko na lang din pala. So, yung gig, di ba? Kung yung MPa, so dagdag natin dito. Kung yung megapascal is equal to Newton per millimeter squared. So, we can also assume that gigapascal is equals to kilonewton over millimeter squared. Okay? Matik yan, as in yan. Okay? No need to solve this one. So, gigapascal is equals to kilonewton per over millimeter squared. So, ngayon, nagawa na natin yung equations of equilibrium tsaka yung mga dimensions, guys. Next, dun tayo ngayon sa compatibility equations. Kung ano yung mga equal sa dalawang material natin. Di ba? So, ngayon, ito yung mga equal. So, of course, yung deformation natin, guys, hindi pwedeng magkaiba yan. Kung yung deformation ng cast iron natin is 0.8 mm, we can also say that the deformation for steel bar is 0.8 mm din, or 0.8 millimeter. So, we can say that deformation 1 is equals to deformation 2. Diba? And of course, kung equal yung deformation nila, equal din dapat yung length 1 and length 2 natin. Okay? So, ayan. So, next tayo. So, ayan na. So guys, so ayun na, actually, yan na yun. Diba, kung equal yung mga yan, pwede natin ngayon ma-solve yung forces natin. Okay? Pwede natin ngayon ma-solve yung mga forces na natin. So, balik tayo dun sa ginawa kong formula. Technically, pinakita kong formula kanina. Diba? We have this formula of deformation is equals to P multiplied by length over area multiplied by modulus of rigidity. Okay? So, we have, so ang i-have natin is yung P. So, sabi natin kung 1 to, so let's say, all of these are 1. Okay? So, syempre, 1, 1, then 1. Then, dahil nasabi natin L1 is equals to L2, we can safely assume L is equals to 2,000 mm din. Diba? So, meron tayong value ng deformation. So, 0.8. So, for ano to? For steel. Okay? For steel yan. So, 0.mm is equals to P1 multiplied by 2,000 mm all over area natin 625 pi 625 pi mm squared multiplied by 200. So convert natin yung GPA into kilonewton para makita nyo guys yung cancellation of units. Okay? Para di na kayo malito kung ano yung magiging unit nung P1 natin, nung other di ba? Okay, so makikita nyo guys, maka-cancel out ito. Okay? And then of course, this one also. Magka-cancel na rin yan. Okay, so technically, our unit for applied load is Newton. Okay? Wala nang hiwagadan ha. So equate na natin to ngayon. So ayan na siya. So dito, solve na natin. So ayan. So 0.8 is equals to applied load multiplied by 2,000 divided by 2,000 divided by 625 pi multiplied by 200. Okay? So, ayan na yun. Shift, solve, 0. So, we have P1 is equal to 157.08 kilo Newton. Okay? Meron na tayo ngayon P1. Okay? So, ayan na. Meron na tayong P1 ngayon. So, next solve natin is yung P2 naman. So, yung P2, ganyan lang din gagawin natin, guys. So, 4 cast iron. Okay? So, deformation 2 is equals to P2 L2 all over area 2 E2. Okay? So, sulat lang din natin yung mga value. 0.8 mm is equals to P2 2,000 mm divided by value ng A2 natin 275 pi mm squared multiplied by 100 gigapascal or kilonewton per millimeter squared. Okay, so what I said, much better isulat nyo yung mga units para hindi kayo malito kung ano yung mga units natin. Para once na mag-cancel out tayo, hindi kayo magkakamali. Okay? So, ayan na siya. Diba? So, ayan. Solve na natin. Ayan ulit naman. Wala naman nagbago. So, 0.8 equals to applied load so we have X or ayan nga, we have P2 is equals to 34.558 kilo Newton. Okay? So technically hindi yun yung final answer. Ang hinanap sa question is ano yung load na magko-compress sa combined bar natin na merong deformation of 0.8 mm. So kailangan ipag-add natin ngayon yung P1. So, balik tayo dito sa equation na to. So, P1 plus P2 is equals to P. So, add na natin siya. Plus 157.08. So, we have, final answer, we have P is equals to 191.638 kilo Newton. Okay? So, ito yung final answer. Okay. Guys. Okay? Ito yung final answer natin for this given problem. Ayun, guys, balik tayo dun sa procedure nga. Doon yung sabi ko. Dahil nasolve na natin yung unang problem. So, first thing first, hanggat kaya, we must, or we always, so, re-require ko sa inyo sa exam. Okay, re-require ko sa exam. Draw the required free body diagram and of course, derive the equations of equilibrium. Okay, so, mostly, as what I said, always, summation of forces along vertical lang naman yung makikita nyo. Okay? And next, derive the compatibility equations. So, geometric relations between deformation. So, technically guys, depende kung given sa problem. If not, mostly yung deformation natin is equal both material. Kung anong material yan, always equal yon. Unless na lang kung nakaangat siya ng 0.5 or anything. Pero, given this, all of the problem na bibigay ko, equal palagi yung deformation natin. Of course, kung equal yung deformation, equal din yung length natin. Okay? And next, sabi dito, to visualize the restrictions on deformation, actually dapat ano yan, comma, it is often helpful to draw a sketch that exaggerates the magnitudes of deformation. So, katulad nung ginawa ko sa ano natin, di ba? Balik tayo sa whiteboard. Technically, ang sabi, deformation natin is 0.8 mm lang. Pero makita nyo sa drawing, sinagad ko talaga siya. Para makita nyo yung deformation. Okay? Technically, 0.8 mm is invisible yan sa mata natin. Technically, 1 mm nga, di natin makita eh. 0.8 mm pa kaya, di ba? Hindi siya ganun kakita pala, hindi siya ganun ka-visible sa human eye. So, exaggerate natin as much as possible para makita natin kung ano yung nangyayari. Okay, so balik tayo sa procedures. So, ayan na. Exaggerate as much as possible. And lastly, use Hooke's law to express deformation in compatibility in terms of force or stresses. So, yun na yung ginawa natin, guys. So, yung Hooke's law natin, balik tayo. This is our Hooke's law. This one. So, ayan siya. Okay, yan yung Hooke's law na tinatawag. Okay? Yan yung equation for Hooke's law. So, meron tayong deformation, meron tayong stress, and then meron tayong modulus of rigidity. Okay? So, ayan yung Hooke's law natin, ha? Huwag nyo makalimutan. So, technically, sa ibang problem, mag-equate yan. Pero dito kasi, hindi ko siya pinag-equate kasi hindi naman siya need. Pero, proceed tayo sa mga ibang problems para mas, para mas makita nyo. Okay? So, balik tayo doon. Lastly, of course, solve the equilibrium and compatibility equations for the unknown forces. Okay? So, makikita nyo sa mga sunod na problems natin, yung paano ginagamit yun. Okay? So, ayan lang muna. Okay, so next, proceed tayo ngayon for our next